Hello everyone, this is Aditya, and today we are going to discuss that why does integration works. But for that, please do like, share, subscribe my channel, and please support the video. Now let's start. So to understand that why does integration works, we have to define a function. Suppose y is equal to f of x, where fx is an arbitrary function, right? Okay. So suppose it looks somewhat like this. Of course, it is an arbitrary function, so it can look like whatever you want. But let's assume for calculation purpose, suppose it looks like this. Okay, and suppose it is going from x is equal to a to x is equal to this quantity, this b, right? So this is f of a, and this expression, this value is f of b, correct? This is the y-axis, this is the x-axis, correct? Okay, so to determine the area under this curve, we use the concept of integration, right? Of course. So for this, what we do is that, let me explain you. Suppose if I say you to find the area of this circle, let me draw it properly. So you have to find the area of this circle, right? And you don't know the formula that area of circle is equal to pi r square. Then what you are going to do? Well, basically you will draw one square first of all inside that circle, and you will find and you will draw a square outside this circle, correct? And you'll calculate the area of this square and the outer square, so that you will have an upper bound for this area of circle and a lower bound, right? So of course the area of circle will be greater than a1, but of course less than a2, right? A2 is the area of this greater square, right? Correct. Simple, right? So if you want to get more accurate result, you can go from a square to a pentagon, then you can go to an hexagon, heptagon, octagon, whatever you want. So there will come a point where you will see that you are coming closer to the area of that circle. So same concept we are going to apply over here, but here we will apply the concept of rectangular blocks. Let's see that. So how we are going to apply that concept? Well, let's see that. So we will divide this region into multiple small rectangles. So for instance, let me explain it. So from here to here, okay, from here to here, and so on and so forth till b, right? And of course the width of this rectangle is very small. It is infinitesimal small, right? So basically, let's assume that this distance, this width is suppose dx. Let's assume that. Okay, so what is the value of dx in this case? Well, it is equal to b minus a divided by the number of rectangular blocks you are drawing, right? Okay, this is the value. So it means that this abscissa will be equal to what? A plus b minus a by n, and this will be a plus b minus a by n multiplied by 2, this expression multiplied by 2, and this is a plus b minus a by n into n, which is b, right? Correct. Over here n is equal to, over here basically this factor is equal to 0, right? So if I want to express a general block in this figure, so what I'm going to do is that I will draw it like this, correct? So this and this, right? So there are 2 points, 2 abscissa, right? So basically if I want to express it for a general case, we will assume it like this. Suppose if I am calculating it for kth block, let's see that. Okay, so this is a plus b minus a by n multiplied by k, right? And corresponding to this, we will have the area as this, correct? Sorry, the value of y as f of a plus b minus a by n into k, correct? Okay, understood, right? Okay, so basically this area we are talking about, right? Okay, understood. Okay, so we need to find the area of all the blocks which can be fitted into this region, and then we have to find the sum, right? So what is the area of this block? Well, let's see that. So basically the corresponding height is this value, correct? Okay, So it is f of a plus b minus a by n multiplied by k, correct? And what is the width? Well, width is a plus b minus a by n multiplied by k minus a plus b minus a by n multiplied by k minus 1. Why k minus 1? Because it is just this abscissa, this value of abscissa is just before the factor of k. So it will be, of course, k minus 1, right? Okay. Which is equal to b minus a by n, right? Which is equal to dx, correct? Which we had assumed that dx is equal to this value. And basically we know that we had assumed that the width is constant of dx length, right? But you can take variable width also, it's totally okay, right? Okay, this expression multiplied by dx is the area of this kth block. Okay, so we have to find the area of such all blocks. So let's see that. Okay, so you can write it as f of a plus k dx into dx is equal to ak. You can assume it like this also. Okay, so basically you have to go like this. The summation as k goes from 0 to n, f of a plus k dx multiplied by dx is equal to the sum of a ak, which is equal to the total area of this region, correct? Okay, so basically where we know that dx is equal to this quantity, right? And this particular expression is expressed as integral of a to b, integral from a to b of the quantity f of x dx. Understood how it comes? Now let's take an example to understand it better, right? Let's see that. So before going to the problem, let's discuss one more thing. I had written k is equal to 0 to infinity, sorry, k is equal to 0 to n, f of a plus k dx into dx is equal to the area, correct? Okay, where I had stated dx is equal to b minus a by n, right? But how do we define n now? Let's see that. So we want that n such that we get the exact value, we get the most accurate value of the region. So for that we want that there we should draw infinite rectangles. So that is why we will have dx is basically equal to limit as n tends towards infinity of the quantity b minus a by n, right? So basically this expression can be rewritten as summation as k is equal to 0 to infinity of the quantity f of a. Let me remove let it be, right? Okay, k is equal to 0 to infinity f of a plus k times b minus a by n, right, into the quantity b minus a by n is equal to area, provided that limit as n tends towards infinity, which is equal to the integral a to b f of x dx, right? Understood now? So where k is there, where k is going from 0 to n, sorry, right? And n is tending towards infinity, correct? Okay, now let me raise this and now let's see a simple problem, right? Now let's see a simple question. Y is equal to x square. Well, its curve looks like this, somewhat like this. So this is the region, some area which we will find. It goes from 2 to 4, suppose x square dx. We need to calculate this area from 2 to 4. So we don't need to worry about this region and this region. And one more thing I need to tell that while calculating the area of that general arbitrary function which we are finding, so in that I assume that the width of each rectangle is uniform, that is dx. But in reality you can take dx1, dx2 and so on and so forth, whatever width you want. It is not necessary that all rectangles will be of uniform width. That is not necessary. We just need to get the area, that is it. Okay, you don't need to worry that we have to take the equal width or not. In either case you'll get the same answer. Okay, so this is 2 and this is 4. So we need to find the area. So we will just apply that formula, limit as n tends to infinity of the quantity summation as k goes from 1 to n, 0 to n, sorry, f of a plus k times b minus a by n into the quantity b minus a by n, right? This expression, okay? So what is b? B is equal to 4, a is equal to 2. So we have this expression limit as n tends to infinity of the quantity k is equal to 0 to infinity f of 2 plus what is 4 minus 2, it is 2. So it is 2 by n into k into 2 by n, right? Okay, right. So how do we open this expression? Well, we know that fx is x square. So f of 2 plus 2 by n into k will be equal to 2 plus 2 by n into k whole square. So you can take 4 as common. So you will have 1 plus 1 by, I mean k by n whole square, right? Which is equal to 4 into 1 plus k 2k by n plus k square by n square. Correct? Simple? Okay. Now just substitute over here. So you'll get limit as n tends towards infinity of the quantity 4 times the expression, this expression, which you will get as, well, 4 you can take common, right? So you can take 4 as common, and from here 2 can be taken as common. So it is 8 times this limit. The summation is from k is equal to 0 to infinity. Sorry, k is 0 to n. Sorry, why I'm writing infinity? I don't know. This 1 plus 2k by n plus k square by n square into 2 by n, right? Correct? Okay. Now we need to evaluate this expression. Let's see it. Okay, let me use this one. Yeah, now let's see. So it is equal to 8 times the limit n tends to infinity. Now let me multiply this stuff over here. So we will get k is equal to 0 to infinity of the quantity, sorry, 0 to n. Here you will get 2 by n plus 2 by n square. We're taking 2 as common, so here it will be only 1. Okay, so here also 1. Okay, yeah. So 1 by n, 2k by n square plus k square by n cube, right? This expression we need to evaluate, right? Okay, so now let's see it. So we get 8 times the limit as n tends to infinity. Summation, what is the summation of this? Summation of 1 is from this to this, it will be n by n plus 2 by n square. What is the summation of k is equal to 0 to n? It is equal to n times n plus 1 by 2 plus 1 by n cube. What is summation of first n squares? It is equal to n into n plus 1 into 2n plus 1 by 6. Correct? Okay. Of course, the summation over k, not over n. So don't get confused. Summation of k is equal to is equal to n into n plus 1 by 2. Summation of k square is equal to n into n plus 1 into 2n plus 1 by 6. You should remember this one. Okay, these expressions. Okay. So now let's evaluate this. This will get cancelled, and you will be left with 8 times the limit n tends towards infinity. 1 plus the quantity, this is 2 and 2 gets cancelled. So you'll be left with n square plus n by n square plus 1 by 6 into this, and this will get cancelled. So you'll be left n square. So it will be equal to n plus 1 by n into 2n plus 1 by n, right? So it will be equal to 8 times the limit as n tends towards infinity of the quantity 1 plus 1 by n, this expression, plus 1 by 6 into 1 plus 1 by n into 2 plus 1 by n, right? So when you substitute, when you set the limit as like this, you will get 8 times 1 plus 1, it will be 2 plus, this is 1 by 6, 1 by 6 into 2. 1 by 6 into 2, it will be 1 by 3. So you get the expression 16 plus 8 by 3, which is equal to what? Which is equal to 48. 48 plus 8 is 56 by 3. This is the area of this region. Well, I think you did not got confused in this limit. Well, basically, I brought this limit inside limit as n tends towards infinity. This expression will become 0, this will become 0, this will become 0, and this will become 0. So you will be left with 1 plus 1 plus 1 by 6 into 2. So it is 2 plus 1 by 3. Multiplied this expression, you get this. And if you apply the general formula x square dx, you will get x cube by 3. It goes from 2 to 4, it will be equal to 64 minus 8 by 3, which is equal to 56 by 3. That is the result. So I hope so that you enjoyed this video. If you did, then please do like, share, subscribe my channel, and please support this video. Bye bye, take care.